and talking about carbon, one of the perhaps most important ecosystem services. So, would you like to say your name?
Yeah, I'm Inés Mazarrasa. Not that difficult, no?
No, that's exactly why I didn't say it. Okay.
Thank you.
Thank you. There's yours, Inés.
¿Cuál? Okay.
So it's that one, isn't it? The left one. So it's that one to go forward, and you scroll to go back. Okay.
Okay, and to point?
No,
do we have a
there's
pointer?
no point.
No? Okay, it's fine. Can I open the screen?
Is that yes?
Okay, it's fine. So, hello everybody. As I said, I'm Inés Mazarrasa. I'm a PhD student at the University of the Balearic Islands in marine ecology. And today I'm gonna present some results of my thesis that relates on the carbon sink capacity of the seagrass meadows formed by Posidonia oceanica. So the loss of natural carbon sinks is the second largest source of greenhouse gases to the atmosphere. Therefore, in order to mitigate climate change, there are some strategies being implemented in order to protect these ecosystems, to prevent CO2 emissions, enhance CO2 sequestration, and also to protect some other ecosystem services such as biodiversity. However, all these strategies have been so far implemented only in terrestrial ecosystems such as forests. Marine organisms are also important carbon sinks, capturing around 55% of the global CO2 captured photosynthetically. Vegetated coastal ecosystems are especially relevant as, despite occupying only 2% of the total ocean surface, they are responsible to 50% of the total carbon sequestered in the sediments, because they have a high carbon burial rate capacity, which has been estimated to be more than 10 times higher to that estimated for terrestrial forests. However, these ecosystems are among the most threatened on Earth, but gaps of knowledge on the mechanisms that regulate their carbon sink capacity and still a scarce number of data on the carbon stocks and the magnitude of these stocks globally prevents the implementation of conservation strategies to these natural marine carbon sinks. Particularly, seagrass meadows are distributed along the coast of Antarctica and provide a wide variety of biodiversity, nutrient cycling, water, are also important carbon sinks. Their high carbon sinks derive from a high activity and also from to capture particles and allochthonous column to the that buffers the water currents and particle trap. A recent study that the largest carbon stocks were located, but it was also between species and also between species, suggesting they play a significant role controlling capacity in this ecosystem, largely unexplored. This point in the Mediterranean Sea. This species is identified so far. Variability between sites exists. The carbon accumulation in meadows is likely hydrodynamic conditions of the site. In previous studies, the meadows sedimentation is favored. Sites erosion. Therefore, we would expect that the will be affected to the in any pressure, usually the physical damage of the pollution and also modification, known to affect seagrass survival, but also to increase the particle load and phytoplankton and allochthonous carbon in the water column. Therefore, anthropogenic pressure likely affects the carbon sources available in the ecosystem. Going back to Posidonia oceanica, it's an endemic species in the Mediterranean Sea, and it is also the dominant blue carbon ecosystem. It is a large and long-lived Spanish species that develops a high below-ground biomass formed by recalcitrant rhizomes that grow both horizontal and vertically, and also it develops a long and dense canopy that is very efficient at particle trapping. The result of this high below-ground biomass and the accumulation of particles from the water column leads to the formation of a typical structure called mate, which is here, that can accumulate vertically, and also it's very anoxic, and therefore carbon can remain buried for millennia. However, the high anthropogenic pressure in the coast of the Mediterranean Sea has led to a general decline of this ecosystem for at least the last 50 years. So the goal of this study was to assess the carbon sink capacity of seagrass meadows since 1900, focusing on the effect of two factors from the seascape, the wave exposure and also the anthropogenic pressure. We did this study in the Balearic Islands, which is one of the top touristic destinations in Europe, and where the development of the touristic industry led to a boom in the population density that took place around the 60s, and a dramatic increase in the usage of the coastal areas that leads to a general detriment of the seashore. Posidonia meadows extend over more or less 600 kilometers square around the archipelago, but again, most of the meadows are generally declining. And we focus on the last century as it is the period when most important changes in coastal areas took place. So we selected 11 different sites under a different level of anthropogenic pressure, with two pristine sites, Escastell and Santa Maria, which are located in Cabrera National Park. We assessed the wave energy using a cartographic method called effective fetch that gives an idea of the relative exposure of different sites. So seagrass meadows located in close bays have low fetch, whereas meadows located in highly exposed sites have high fetch. And in order to assess the effect of anthropogenic pressure, we used population data for the last since 1900 from the closest town to our site of study, and we visually identified two periods, the period before and the period after the onset of population booming. So we went to the field and we manually extracted 3 cores per meadow, manually hammering PVC tubes, and once in the lab we sliced the core every 1 centimeter, and from each slice we measured dry wool density, grain size, organic carbon, and we also estimated the age of the sediment using lead 210 technique. From this, with these variables, we measured granulometry and we estimated the top meter carbon stocks and the carbon burial rates since 1900. And in addition, based on the age of the sediment profile and the approximate date that we identified when the anthropogenic pressure increased in its site, we divided the sediment cores in 2 periods, the period before and the period after anthropogenic pressure increased, to be able to compare carbon burial rates between those 2 periods. Moving to the results, the meadows examined stored an average of 200 megagrams of organic carbon per hectare, but we found significant differences between sites. Taking in account all the surface occupied by Posidonia meadows around the islands, this ecosystem stored an average of 47 teragrams of CO2 equivalent, which is more than twice the carbon or the CO2 estimated to be stored in the biomass of the forest of the same region. Regarding to the carbon burial rates, the meadows examined showed an average of 26 grams of organic carbon per meter square and per year, which is 5 times the average burial rate estimated for temperate forests globally in the sediment. Again, taking in account all the surface occupied by these meadows, this ecosystem stored an average of 63 gigagrams of CO2 per year, which is comparable to the CO2 absorption rate estimated for the forest biomass. but again we found significant differences between sites. When we look at the effect of the wave exposure, these graphs show the wave exposure in the x-axis, again the segment grain size in the left panel, and the carbon burial rate in the right panel. So moving from left to the right in the x-axis, we go from the most sheltered meadows to the highly exposed ones. And we found that the segment grain size significantly increased as the exposure of the meadows increased in the left panel, indicating that sedimentation is favored in shelter size, as we expected. However, the carbon burial rate was not significantly related to the exposure of the meadows. It is true that the most exposed site showed a very low carbon burial rate, as we expected. But the carbon burial rates in the more sheltered meadows, so in the left side, in the sheltered ones, are very different. And in fact, the most pristine sites show lower burial rates than the highly anthropogenic impacted sites. This suggests that anthropogenic pressure influences the carbon burial rate in these meadows. And in fact, we found that the carbon burial rate for the period after anthropogenic pressure increase was on average 69% higher than the carbon burial rate for the period before. This is reflected in this graph. If we see the y-axis, it represents the ratio between the carbon burial rate for the period after anthropogenic pressure increase divided by the burial rate before. So points over the line 1 correspond to meadows that or where the carbon burial rate increased for the most recent period, which is the case for all the meadows of the study except 2. But how can we explain this? Let's think about again in the two sources of carbon to the seagrass sediment stocks. We have first the seagrass biomass. But as I said before, the meadows examined are declining. Therefore, it is not likely that the observed increase in the carbon burial rate could be explained by an increase in the seagrass productivity. On the other side, we have the allochthonous carbon in the water column, cestonic particles, and phytoplankton, which has likely increased for the last decades associated to the increase in anthropogenic pressure. We have to point out that allochthonous carbon, especially phytoplankton, is more labile than seagrass carbon, therefore is more vulnerable to be remineralized. So to conclude, in the Balearic Islands, Posidonia meadows store more than twice the carbon stored by the forest biomass in the region, and show an average burial rate 5 times larger than that in temperate forests globally. Wave exposure was determinant in the patterns of sedimentation in the meadows examined, but was not enough to explain the carbon burial rates. Carbon burial tended to increase with increasing anthropogenic pressure, likely due to an increased accumulation of allochthonous carbon more labile than seagrass carbon, and therefore more vulnerable to be remineralized. Posidonia meadows in the Balearics are important carbon sinks, but the anthropogenic pressure in the region is leading to the decline of this natural carbon sink and might be changing the sources of carbon being burned, lowering the resilience of the carbon deposits. And finally, we consider these meadows as good candidates for testing the implementation of blue carbon strategies that would favor the conservation of these natural carbon sinks. Thank you very much for your attention.
I must apologise because I should have given you the microphone, but everyone could hear. I was looking and you presented brilliantly. So.